Hi everybody! So in our last video we took a look at the small interference figure projectors and how they work. In this video what we're going to do is take a look at how you can make your own customized version using a kit from Snellius Minerals. Let's first review what the small interference figure projectors are. Here we have a variety of the small interference figure projectors, and we've got two different styles of this device depending on what you want to do with it. In taking a look at these devices from the side, we can label all the different component pieces of each. These are fairly simple and they consist of a sample sandwiched between two linear polarizers. Some of these versions have something called a light diffuser and some of them do not. That just depends on what experiments you want to do with your small interference figure projector. And all these pieces are then held together with a 2 by 2 inch coin flip. Let's take a look at some of the fun experiments that we can do with our assembled devices. For the interference figure projectors that lack a light diffuser, we can actually look through them, and we'll see something called an interference figure. This pattern of light, color, and darkness is actually a result of light interacting with the crystal structure of the mineral we've chosen as our sample, as well as the orientation of our mineral and the orientation of our linear polarizers. So if we didn't have a crystal in our device with this particular orientation of linear polarizers, you wouldn't see anything because the device would actually block out almost all the light traveling through it. Our crystals of certain minerals do interesting things to light as the light travels through them because of their structure, an orderly internal arrangement of atoms that repeats over and over and over again. And this means that the physical properties of our single crystals of a mineral can vary with direction through that crystal. This is something called anisotropy, and it's important in identifying minerals and also using these minerals in industrial and high-tech applications. Right now, we're not really getting the full effect of this interference figure, so I'm actually going to tilt the device a little bit, and you'll be able to see a bit more of the pattern. While the devices we're looking at today are intended for educational purposes, there are also practical applications for these effects, some of which are detailed in the book Rings of Fire. This book explores the generation of the optical ring sight by Polaroid during World War II, and more information on all of this can be found in the video Snellius Minerals Optical Ring Sight from World War II. When we're viewing through our small interference figure projector, we're effectively doing something pretty similar to the optical ring sight. However, using minerals other than calcite for these educational kits is cheaper and easier. So we took a look through our small interference figure projector. Now let me show you what happens when we shine a flashlight through the interference figure projector in a dim room. This is the same device that we looked through earlier, and here you can see that interference figure projected onto the wall of our dim room. I'm going to add on an image of what the view through this device looked like, and we can see that the interference figure is the same in both cases, however just a little bit more cut off with our original view. Let's now run through some other interference figure projections. These are using a variety of different minerals and different orientations, and they're detailed in the video Snellius Minerals Small Interference Figure Projectors. The video is running at double speed and is just here to give you a sense of some of the fun, interesting patterns we can generate using these techniques. But really, the point of the small interference figure projector kit is so that you can use these techniques on your own, so let's take a look at one of these kits and how we can put one together. Here's all the pieces included in the kit. There's a baggie for all the pieces, a 2 by 2 coin flip, 2 linear polarizers, a sample, in this case a plate of muscovite mica, and a light diffuser, which is just a piece of tracing paper. Let's go through step by step how we can take our kit and assemble a small interference figure projector. With the pieces in this particular kit, we can make an interference figure projector very similar to the first one I showed you in this video today. We'll start by taking one of our linear polarizers and putting it into our 2x2 coin holder. We then add our muscovite mica plate on top and the second linear polarizer on top of that. Now here we have to pay a bit more attention. Our linear polarizers are cut so that one set of edges is parallel to the vibrational direction of light that it will allow to pass and the other perpendicular. And at this particular moment for our device, our two linear polarizers actually have their vibrational directions perpendicular to one another, and this is known as crossed polarizers. If you'd like to learn more about linear polarizers, you should check out the video Snellius Minerals LLC Linear Polarizers. You can tell the polarizers are crossed in this view because where the two linear polarizers overlap, you should see black. Now if I rotate 90 degrees, you'll see some light being transmitted through the polarizers, and back again to crossed polarizers. So we've left out the light diffuser in this scenario so that we can use this device in a manner similar to an optical ring sight. And let's use our coin holder to sandwich everything together, and we can actually bring the whole device up to our eye and take a look through. And we see a pattern pretty similar to the original interference pattern we saw with the first device in this video. Everything is rotated 90 degrees, however. Let's see how this device works for projecting an interference figure, and in order to do that I'm going to turn off the lights to this room and then shine a flashlight through the device. And we get a nice projected version of our interference figure. We can make this projected version a bit better by adding in that light diffuser that we talked about earlier. Adding in the light diffuser means we can no longer really look through the device, but the projection is much more complete, as you can see here. Here's a side-by-side comparison of the two, with the image without the light diffuser being in the upper left. And the interference pattern here is rotated 90 degrees, but that's not an actual difference. I just accidentally rotated the device 90 degrees. So just a bit of nomenclature to talk about the different pieces of our interference figure. One of the most striking features of our interference figure are the isochromes, and these are lines of the same color that you can see in the pattern. Here I picked the blue isochrome to draw arrows to. Another important piece of our interference figure are going to be the isogyres. These are bands of darkness, and they extend outward from and rotate around a specific point known as a melatope. There's much more detailed information on all of this in some of the other Snellius Minerals educational videos, but those are the important pieces for talking about our interference figures today. So there are all sorts of different ways you can change the orientations of our muscovite mica and our linear polarizers in order to produce different patterns. Let's take a look at a couple of them here. What we'll try for this first experiment is I'm going to rotate one of our linear polarizers 90 degrees, and everything else will have stayed the same as we do this projection. Rotating that polarizer by 90 degrees means our linear polarizers are no longer crossed, and now the vibrational directions allowed through each of our linear polarizers are parallel to one another. Here's a side-by-side comparison of our two different interference figures. The upper image has our polarizers crossed, and the lower image has our polarizers aligned. You can see that this changes primarily the isogyres. In the upper image, our isogyres are the dark bands, and in the lower image, they are white. Our interference colors also shift a bit between the two different patterns. Alright, let's try out another experiment. We'll put our polarizers so that they're once again crossed, and we'll rotate our muscovite mica plate 45 degrees. We're also going to keep our light diffuser in place to do all the future projections in this video because it just makes them a bit better. Let's check out what the pattern looks like now. And I didn't get everything quite perfectly aligned, but this is still pretty good. Let's compare this interference figure to our previous version where we had our muscovite rotated 45 degrees and still had crossed polarizers. Much of the differences we see between the two of these is in the position of those dark isogyres. If we slowly rotated our muscovite mica plate degree by degree in our projector, we'd be able to see those dark isogyres actually rotate around the mellotopes of our interference figure. And an educational example of this can be found in the video Snellius Minerals Oriented Muscovite Mica Sheet. And that's an excellent example of an experiment that you can try out on your own with this kit. Let's do the same style of experiment that we did before, where we take one of our linear polarizers and rotate them 90 degrees so that our polarizer's vibrational directions are parallel again. And with this interference figure projection, you can see that once again the isogyres have become white instead of dark bands as before. Here's a side-by-side comparison to show the difference. These are just a few examples of the different experiments that you can do with the small interference figure projector kit. Other versions of this kit include 2 pieces of muscovite mica that you can make interfere constructively and destructively with one another, as well as phlogopite mica. To review what we did today in our video, we took a look at a variety of small interference figure projectors that were already made. These consist of a sample sandwiched between 2 linear polarizers and may or may not contain a light diffuser. If the projector doesn't contain a light diffuser, we can actually look through it in a manner similar to an optical ring sight. We then see an interference figure superimposed upon our field of view. This device can also be used to project an interference figure by shining a flashlight through it in a dim room. And by changing our sample material, the orientation of our sample, or the orientation of our linear polarizers, we can generate all sorts of different interference figures. And these interference figures are telling us about the symmetry of the structure of our crystalline sample. The small interference figure projector kit allows you to do a variety of these experiments on your own. You can investigate things such as how a light diffuser improves the quality of our interference figure projection, or how the orientation of our linear polarizers influences our isogyres, or how the rotation of our muscovite mica plate influences the interference figure produced. You can find these kits for sale, along with others, at the eBay store Snellius Minerals. One of the best ways to learn about minerals and optical mineralogy is to play around with these concepts for yourself, and I think that's really the strength of these kits. If you have any questions for me or specific requests, you can reach out to me at snelliusminerals@gmail.com. Here are the references that I used in the creation of today's video. Thanks again for watching, and have a great day.